Right, so today I wanted to talk to you all about a little something called uniform circular motion. And you're probably wondering, what is uniform circular motion and why should I care? Well, I'll tell you. Uniform circular motion is that motion that you go in a circle that is constant. So your speed doesn't change. And why should you care? Well, let's say you had a little house that was 4x4 meters wide, and in the middle of your 4x4 meter house, you had a chandelier that you wanted to swing from in a circle. So this is the view from above. Now, let's say the radius of this circle was 3 meters because you don't want to hit any of the walls of your 4x4 meter house. What would that look like? Well, you've got your chandelier here, and now your chandelier is actually going to be swinging at an angle. We'll call this rope 5 meters, let's say, and the weight of you and your chandelier is 150 kilograms. Now, how fast can you swing from your chandelier? That's a pretty good use of UCM, I would say. Well, never fear, because we're going to work it out. So this line here is 3 meters. Remember, that's our radius. So this is now looking at it from the side. The first step in a question like this is you want to draw a free body diagram of you and the chandelier and see what forces are acting on you. So I always start with FG, because that's the easy one, that's the weight, and that's always going to be acting on you in a downward direction. And then the only other force acting on you here is actually just the tension acting up towards the top there. Now, your weight is easy to work out. That's just your mass times gravity. We'll sub that in there, and we get wonderful 1,471.5 newtons. And the reason why that's important to us is because this tension can actually be split into a vertical and a horizontal component. We'll call it Tx and Ty. Now, Ty is equal to the weight in this case, which we've just worked out. And we need that to work out Tx. But we can't just yet, because we don't have enough information. What we need is this angle here. But don't sweat it, because we can work that out, because we've got a triangle here. And if you'll do a little bit of trigonometry for me, we'll know that sin of this angle, we'll call it theta, is opposite over hypotenuse. Yes? Okay, good stuff, good stuff. Plug that into your calculator, and you'll get 36.87 degrees. Now, using another little bit of maths here, as you can see from this diagram, this angle is theta. We can actually see that this angle is equal to that angle, because these two lines are parallel, and it's alternating angles. All right. I hope I haven't lost you yet. So now we've got this angle, we can use more trigonometry. We've got tan theta equals the opposite over adjacent sides. Yes, Tx over Ty. Sub that in. And what we'll find is that our tension in the horizontal direction is equal to 1,103 newtons. Now, this is also some good stuff, but you're probably wondering, why did we bother working all of this out? Well, I'll tell you. This is where we use some of our UCM principles. So the deal with uniform circular motion is that it acts towards the center. What do I mean by that? If you were swinging on a chandelier, you would probably feel like you were experiencing some force outward. But that's a misconception. That's not actually what's happening. What's actually happening is your speed is not changing. Your tangential velocity is remaining constant. That's what we're trying to work out now. And it's tangential, it acts perpendicular to your motion at a point. So I'm drawing it now in green. And what's causing you to continue spinning in that motion is actually an acceleration acting towards the center of the motion. And that's your centripetal acceleration, which in this case is caused by the tension. Now, what you experience, this sensation of feeling like you're moving outwards, is actually just inertia. Right, so now that we've gotten that out of the way, we can use Newton's second law, which is very useful because our net force here is our centripetal force, which we've just worked out. Because the centripetal force here is actually just the x component of our tension. So we'll sub that in. We know the mass. Our mass is 150. And what is our acceleration? Well, centripetal acceleration is given as velocity squared over r. And lucky for you, this is what we came to look for. And what is our r? Well, it's our radius, which we already have. So filling in this equation, finally, And doing a little bit of math, we can work out that our velocity is 4,7 meters per second. Wow, isn't that lekker? So if you were ever in a 4x4 meter house and you had a chandelier that was hanging on a rope of 5 meters, that's how fast you could swing without bumping into the walls. Isn't that nice? I hope you feel glad that you've now learned this, and now you know why uniform circular motion is not completely a useless skill to have. Right.